Hello, it's Avionics Equipment of Aircraft, and today we will continue our long talking about onboard equipment of civil aircraft. And today we will talk about basics of packaging. As you remember, on board we have a lot of systems and a lot of electronics equipment as well. And many years ago, it was a big challenge how we can place all of that stuff on board. And specific packaging standards has been invented. And since that time, we use specific packaging standards for all avionics equipment, especially about main system components of particular equipment. That's why today talking about packaging of onboard equipment of aircraft. First of all, let me introduce you an line replaceable unit concept. Based on this idea, all equipment on board of aircraft we need to divide into specific boxes, which we called LRU, and which means line replaceable units. It means that we need to use LRU to develop new systems and to put it on board of the aircraft. LRU have logical function boundaries associated with a particular system to perform on board of aircraft. Usually one system use one LRU. Thus, LRU is just a box in which we can put some system stuff. And this box gives us big possibility for easy removing, easy repairing system components, and of course maintenance of onboard equipment of aircraft. Based on system design, different size we required. It means that for small systems we need quite slim box. For quite complicated system we need more space for electronical equipment. That's why scientists try to think how we can make a flexible approach for packing avionics. And in this case they develop LRU approach, and all LRUs uses the same height, because usually, as you can see, these LRUs we put at specific place in the shelf of avionics. That's why each LRU it's optimal to have identical height. However, different widths. About depths we will talk a little bit later. And it helps a lot for different applications. However, what's the point of LRU? Just imagine that we have a lot of different electronical components and a lot of small pieces and maybe some analog very high frequency parts, and all of that we need to divide into specific amount of boxes. Thus, first of all, we need to think how we can divide all this equipment into particular box, or what kind of equipment we need to put in this box, what kind in another box, and in the other sort of box. And the first one, it was system boundary. It means it is a good idea to put everything that we need for system operation in one particular box. And it means that if we've got some malfunction or we've got fault in system operation, thus we just need to unplug particular box and replace it with a new one. That's why division into the system level of whole avionics, it makes sense, because we just need to unplug system which does not operate and put the new line replaceable unit. And it happened maybe many years ago, and since that we've got the same structure. Thus we have multiple LRUs, and each of LRU usually holds components of one system. However, how we can play with these boxes on board of aircraft? And the first that we need to do, we need to think about standardization of these boxes. And ARINC company developed a set of standards for on-board avionics packaging. And inside of these standards, they've got description of dimensions for particular box. And also they've got description of connections of each box to the onboard system. It means that ARINC has a standard for packaging, and this standard includes dimensions for sizes of this system and includes description of interconnection in the opposite side of LRU. Also, it describes how system should operate and what kind of signals it can provide. Then, this standard can be used on both sides by developer of aircraft during the preparing their onboard wire connections and onboard Avionics Bay, and by multiple vendors in the market, which can develop particular systems independently from other side. That's why it gives the multiple advantages at the development side, because anyone can develop their own system with the specific algorithms inside and specific technical realization of this algorithm inside of each LRU. Because in standard we do not have any words about technical equipment inside of line replaceable unit. That's why it means that everyone can develop the same system, and then airline or aircraft manufacturer can just choose the system and with the same standard, and then it means that this system will be operable on board of this aircraft. In particular case, if we look on line replaceable unit concept, for example, distance measuring equipment. On board we have particular LRU with all equipment for DME. That's why we have a standard, particular standard for DME. It is ARINC SAM 709. And according to this standard, manufacturers can develop different systems of DME. For example, Rockwell Collins, Bendix King, or Honeywell, or many others can develop the same systems. And then these systems can be easily replaced for any other system with the same standard. It means that LRUs developed by standard is not multi-purposes, however, easy replaced with another system with the developed with the same standard. And it gives a huge advantage because, first of all, it is economical part. Just imagine that you can develop system, and this system can be placed on board of each civil aircraft. It means potential any airline or any aircraft manufacturer can buy your system, and it means that price for system can be reduced because manufacturers have quite wide market for this system because anyone can bought it and put on board of aircraft. That's why price for equipment, it is important point. That's why using LRU makes reducing price for avionics equipment. Next important point, it is maintenance. As you know, on board of aircraft we have nowadays we have a lot of computer-based system, and actually each system on board, it is a small computer. It means each LRU, it is a computer-based system, and inside of each LRU we have built-in specific algorithm for self-operation monitoring. And in case if this self-operation system detect some fault or malfunction, that's why this LRU will indicate its health status of some fault. And also we have a specific system which can record all of the data, and it means that during the landing of aircraft, specific engineer can be on board and copy the data about operation of all systems, and then just using USB or drive or flash card, and then move this data, move this log file to their specific computer application, which can analyze and indicate for maintenance personnel where we have a problem, and indicate that, for example, this system needs to be replaced. And maintenance personnel just go on board, then unplug particular LRU and put the new one. Then press particular button and LRU will be on, and then wait a few seconds until initial test will be done, and then aircraft is ready for takeoff. That's why LRU helps to solve particular problems with system equipment in a few minutes, and of course it very welcome for any airline. And also another quite important thing, that if you've got problems with one box, you remember that any maintenance personnel cannot repair line replaceable units, because only specific service department of particular company can open the LRU and provide some services. That's why maintenance personnel on board of aircraft only using simple function: detection of fault, then testing if fault is present, then just unplug and plug a new LRU. And then aircraft is ready for takeoff. And this is important thing because for airline it saves time, because we cannot wait until someone repair LRU and their multi-million aircraft will stay on the ground, and airline have to pay fees for staying on the ground, paying fees for passenger recover. That's why it is not a good idea to stay without work. That's why each aircraft should work, and this is an important element of any airline life cycle. Let's go next. Thus, what we have on board of aircraft, each system will be packed at the particular box. Okay, most part of system is packed in a box which we called Line Replaceable Unit LRU, and this concept also called LRU approach. Then each LRU at the opposite side has particular connectors, and for particular LRU we have specific trays. It means that tray it is a specific mechanical construction which hold LRU safely and provide like plugging and unplugging LRU speedy. That's why it looks like this one. It uses specific like knobs for mounting LRU. Thus you just need to roll this knob and you can unplug or roll it in opposite side. LRU will be hardly fixed in the tray. That's why trays, it is a specific holders for LRU. And also these trays are developed for particular system, because for different system we need different connectors at the outside of LRU. That's why each particular system use specific trays for holding specific LRUs also. All of these trays are packed or are placed in the specific shelf. That's why the main idea to have the same height for LRU, because all of this equipment will be placed at the one shelf with the one dimension. That's why all of these shelves also packed in a specific avionics bay. And inside of this bay we have a particular environmental condition. For example, specific temperature, specific pressure, and specific humidity. Usually avionics bay requires different condition that we have in passenger cabin. That's why, if it is possible, avionics bay developed separately from their other inside part of aircraft, other than passenger cabin. And they use specific air condition system that can hold some part of air outside of the aircraft, then move through the Avionics Bay, because during the operation of some electrical components inside of LRU, it produced some temperature, it produced some heat, and finally we need just to move this hot air from the LRU and move it out of the aircraft. That's why specific air condition system usually used on board of aircraft to support Avionics Bay operation. Previously, I hope you remember that on board of aircraft we have electronics, and the main problem of the whole aviation that electronics is changed, and there are three basic generations, and during each generation of avionics, sizes and dimensions of LRUs has been changed significantly, because first of all it was vacuum bulbs, yes, inside of electronical equipment, then it was transistor, and now we have mostly microprocessor devices. That's why boxes, which was introduced after the Second World War, also not optimal now. That's why in standardization, ARINC have to use different standard. First of all, after the Second World War, ARINC developed series of standards, ARINC 400 or ARINC 4th generation, and in this series they describe air transportation rack. ATR, it is a title of LRU which specified in ARINC 400 series. A little bit later, you remember that vacuum bulbs, which was present for 20 years after the Second World War on board of aircraft, has been changed to transistor equipment, and boxes, which was developed for vacuum bulb, became not useful, because there are multiple spaces inside of each LRU, because equipment has been reduced in 4 times or more, and and the internal structure also has been changed. And finally, they developed a new standard, which they called ARINC 600 series, and in this standard they described MCU or Modular Concept Unit. Thus, MCU, it is another title for Line Replaceable Unit, which is much more lower than ATR, because ATR was mainly developed for historical electronics. It was developed and oriented into the vacuum bulbs equipment. That's why ATR was quite works for big electronical stuff, and MCU was oriented mostly in transistors, microschemes, and microcontrollers as well. First of all, let's talk about ATR. They develop one particular size for ATR. Thus, it was one ATR. It is like a title of LRU. And also they developed some less box, which is half ATR, 3¼ ATR, and 1½ ATR. And these boxes was quite oftenly used. Also, there are many other up to 2 ATRs. However, most of them, it depends on particular requirements of equipment. ATR Series LRUs uses the same height with approximately 27 centimeters shelf. Then they use two different types of depths of each LRU. There are ATR short series and ATR long series based on equipment possibility and Avionics Bay structure on board of aircraft. Short series has been approximately 32 centimeters depth, and long series a little bit longer, like 49 centimeters. Width of each LRU was different. Thus, one ATR width approximately 26 centimeters, and all other ATRs has lower or bigger widths for particular ATR sizes. The same widths we have in long series. Also quite important, try to remember that ATR use the same height and two different series of depths and different widths for each ATR based on number of this ATR. Also, to make possible to put different ATR boxes in different shelves structure of aircraft, it was developed 3 different types of trays for these LRUs. Thus, we have a short tray for short ATR series. We have long tray for long LRUs, and we have long tray for short LRU. That's why any type of LRU can be installed on board of a particular tray of aircraft based on available LRU modules. Next, quite important that all of these LRUs with the trays will be installed at specific shelves at their Avionics Bay. Thus, here is an empty shelf for avionics developed from dural aluminum, and it has multiple trays for particular LRUs based on system. Also remember that each system has a particular LRU and particular tray. That's why we've got different trays for different systems. Then this shelf will be installed in the Avionics Bay. Here's an example of Avionics Bay. And then line replaceable units will be installed into their these trays of avionics shelf. And finally, it will be operated. Here I have a description of a few examples of ATR boxes. Also, take attention that at the front panel of LRU, usually we have some filter for filtering air, because at the opposite side we have cooler and cooler engine, and airflow will be goes through the LRU from the front to the opposite side. Thus, part of air will be caged outside, then goes through the filter equipment, and then goes away at the opposite side of LRU. We need to use filter to reduce number of dust, to reduce some mechanical elements in the air, to more protect electronic devices inside. Actually, the main task of LRU is protection of electronics inside from different dangerous factor influence, and including like dust and some other components which may be present in the air. And also, this is one of the causes why Avionics Bay should be isolated from the passenger cabin, because dust it's a real problem, not only on board of aircraft and for all other electronical equipment. As I told you, that after microchips are coming, ATR boxes became very widely, and there are free space, because just imagine that previously we have multiple light bulbs, we have multiple sockets to prepare like electrical signals for these light bulbs, and after that we have small microchips and transistor equipment, and electronics, size of electronics reduced significantly. And according to ATR standard, we have wide box. However, modern system design on microchip requires, for example, in 10 less size, and it means that they use like small piece of mounted board for electronic device inside of empty box of ATR. That's why it was not efficient, because the space in Avionics Bay was distributed not optimally. That's why a little bit later ARINC developed a new standard series and called these boxes or ATRs by MCU title. That's why modular concept unit is described by ARINC 600, and one MCU box was like basic LRU for mounting different systems. The same with ATR. MCU uses the same height, and it was 7 and 6 degrees for height. Then depth of each box became 12 and 0.7 inches. Width of each LRU depends on size. If you have one MCU size, it means we have width 1 and approximately 27 inches. However, for different sizes, we have a formula by which we can count width for this box, which told us that width is equal number size multiplied with 1.3 and minus 0.032 inch. That's why MCU became an approach for modern, okay, for those time it was modern approach for up-to-date electronic components. That's why ATR mostly based for vacuum bulbs. MCU it is much more slim, okay, and developed for modern electronic components. MCU and ATR uses in parallel, and it depends on aircraft manufacturer, it depends on airline, because life cycle of aircraft may be quite long, and that's why at particular case modern aircraft and old-fashioned aircraft can be operated at the same time. That's why it based on aircraft, it based on particular case of avionics structure. Thus, in any case, MCU, the same to ATR, it is only a box. And what we can put inside of this box, it is absolutely manufacturer's idea. That's why in standard we do not have specific description of algorithms or some particular elements that can be used inside of each LRU. That's why MCU and ATR, it is boxes, specific boxes for avionics equipment. However, in standard we have particular box size for particular system. It means that on board of aircraft manufacturer prepare specific tray and connect connectors to this tray. And if aircraft manufacturers use particular standard, it means that any system according to this standard can be used on board of this aircraft. Here you can see that there are a big variety of MCUs. However, MCUs mostly use only integer sizes. It means that we have 1 MCU, 2 MCU, 3 MCU, 4, 5, 6, 7, and goes next. That's why we have only integer numbers for MCU sizes. If we can compare a volume of 1 MCU and volume of 1 ATR, then we can tell that approximately 1 ATR is equal to 8 MCU. That's why we can see that 1 MCU is less in 8 times. And approximately we can also tell that introduction of transistors and microschemes, microchips give us possibility to reduce avionics in 8 times. However, it's like something not actually true, because this is different number ideas. However, yes, we can tell it in some particular cases. If we talk about internal structure of LRU, nowadays it looks mostly similar to personal computer structure. We have metal box for elements, yep. We have particular electronic mounting boards and some electronics devices. We have power supply unit, and we have some cooler which move air mass through the front, then through the electronical components of LRU, and then goes away from LRU. And in this case, all electronical equipment will be cooling. That's why this is the idea how we can remove heat from LRU. Next, quite important that on board of aircraft usually we have two power supply networks. One network is a DC current, and the next one is alternative current. Usually DC current can be 28 volt, 27 volts. It depends on manufacturer. However, 27 or 28 volts are used for direct current. Alternative current also can be different. It can be 115 volts or 36 volts, and different frequency can be used. Thus, inside of each LRU, ATR or MCU, we need to use power supply unit to reduce power to more lower values to support some microprocessor elements. Usually 5 volts or 15 volts are used. Thus, power supply unit needs to reduce a level of voltage to support microcontroller elements. Then, inside of particular LRU, also we need to have some processor equipment or microcontroller with memory. We need to use some network equipment to operate with all other LRUs in the shelf. That's why, for example, ARINC 429 receiver or ARINC 429 transmitter can be used to exchange the data between this LRU and another LRUs. Processor, memory, network equipment, and possibly all other devices inside are connected together with the help of some internal database. That's why usually we've got some bus, and all this equipment is connected to this data bus for data exchange between these elements. Also, some sensors can be used inside of LRU. Some set of analog to digital converters and opposite digital to analog converters. It's based on system type and based on particular operation and sensors which interrogate with this LRU. And probably some other stuff, for example, high frequency electronics, or maybe some receiver circuits may be present in LRU. In most cases, LRU have to provide not only security of electronical devices, it should to protect this electronic device from specific condition of environment, and it includes external voltage surgery and static electricity. That's why LRUs are definitely developed with a metal cover. This box have to be metal because static electricity or electromagnetic interference generates small currents, and if we cover our electronic components and sensors with a metal holder, it means that most influence will be accumulated in this metal construction, and then we just try to remove this current out from these boxes. That's why all LRUs is a metal boxes, not only to provide like mechanical protection. However, from electromagnetic induction and static electricity, it is important to use metal box. And of course, it should provide some protection from some physical effects like vibration and influence of dust, extremal temperature condition, and some other things. On board of aircraft, we have a lot of sources of electromagnetic induction. For example, high voltage generators near the engine, or maybe some LRUs with a transmitter, which use like magnetrons for generating high frequency radio waves. And it means that LRU itself can be a source of electromagnetic interference. That's why this metal cover helps to protect at first elements of LRU from external action, and then protect all other LRUs from some elements which can transmit electromagnetic noise. That's why this metal cover protects a lot internal and external ideas of protection. In physical effects, quite important is a vibration, because during the flight we have a vibrating condition. That's why avionics trays should to be mounted at some mechanical construction which can absorb vibration in order to reduce vibration at the inside of LRU. That's why it's solved on the trace level. That's why LRU is hardly connected to tray. However, tray is connected to shelf via within the specific vibration absorbing elements. Then protection from action of extremal condition of temperature and altitude. Altitude, it is important because it connected with static pressure, and usually Avionics Bay uses a specific air condition system to provide separation from the passenger cabin. That's why altitude, it is connected with static pressure, which may be different than we have outside of cabin. And also fog, dust, sand, and fungi is also important. That's why we've got some filtering in some side of LRU to absorb all of these particles in this filter, and then provides cooling with much more free space. That's all for today. Please try to remember that LRU plays an important role because without line replaceable unit we cannot maintain our avionics on board. That's why all system components have to be divided into the LRUs. We have two basic standards for these LRUs, ATR and MCU. And the idea why we have two of these standards, it is because changes in generation of electronics. This is important. That's why please try to remember it. That's why thank you for watching. Hope to see you next time. Bye.